Hello, I'm Rich Sportsman with Vinmetrica, and today we're going to take you through the latest updated version of our SC-50 malolactic fermentation testing kit. We made a couple of small changes to the kit. Those of you who've used it before will see a few of the changes in it, and we just wanted to give all of our users an updated example of how we actually run the test here in our lab. Everything that we're going to be doing today is in the manual, but sometimes, as you all know, it helps to see it done live. The first thing that we're going to do is, as the manual suggests, prepare the tubes with the biopressure agent so that you're ready to go in the future. You can make these tubes up in advance and store them in the freezer. So in your kit, you'll get a vial of the biopressure agent. Make sure it's at room temperature before you do this. Go ahead and open it up, and then take your tubes, which can be either, some of them will come in amber, the newer ones will tend to be coming clear, but either one works fine. Take off the septum cap, and take your spoon that we provide in the kit, and you're going to put in 2 level scoops. 1, 2. If you happen to have a really sensitive balance around, you can weigh out 40 milligrams, plus or minus a couple of milligrams is good enough, and that will provide you the appropriate amount of the biopressure agent to proceed with the test. Then you can put the caps on, and you can put them away in the freezer or refrigerator, preferably freezer, until you're ready to use them. Now what we want to do is take you through the procedure for preparing your wine samples. This procedure is pretty much the same. We've added an additional dilution step to it, so follow me as I go through this. I've got 2 wines here. One of them is a Cabernet Sauvignon, the other is a Pinot Noir. We know the Pinot Noir, because we've tested it already, has a very low level of malic acid left in it. It is completed MLF. The Cabernet Sauvignon has not completed, and it has a relatively higher level. So what we're going to do is, as the manual suggests, and this is important to do, we're going to pipette 10 milliliters into these tri-stir beakers. We're going to put them in the microwave, bring them to a boil for about 40 seconds or so, depending on your microwave and heat and so on. And the goal is to get that 10 milliliters down to around between 6 and 8 milliliters. That's a good target to hit for. That way we know we've driven off all the alcohol and have also driven off any residual gases that are dissolved in the wine ahead of time. So I'm going to take one of these samples for you to show you how that's done. We don't need to do both of them right now. So I'm going to suggest that it's a good idea to use a pipetting bowl, because some of the things you pipette in the chemistries that you do may not be very good to get in your mouth. So it's always a good idea to use a pipetting bowl. And so I'm going to use this bulb that is available from us, not necessarily part of the kit, but you can get them available. And I'm going to draw up above the 0 point, and then I'm going to very carefully let it fall down until it's right on the 0. And I'm going to dispense that into my tri-stir beaker. And I'm going to let it run all the way down to the end. Technically, don't blow it out, just leave it go down to the end. I'm going to leave it right here. And if you have other wine samples, you'll want to do the same thing with those. But for the purpose of today, I'm just going to show you one. So now we're going to take this over to our microwave and microwave it till it comes to a slow boil. So I've put the beaker with the 10 milliliters of wine sample into the microwave. And by the way, you can put in multiple beakers at the same time. You just want to make sure they all spend about 30 to 40 seconds at a moderate boil. Right now I'm just going to do one. I'm going to put my power level down on 5 because I know in advance with this particular microwave that gives a moderate rate of boiling that gets the job done in about 40 seconds. Then I'm going to hit the thing and start, and we'll sit there and we'll watch it. And if you can see through the screen on your microwave, you want to keep an eye on it. And first of all, make sure it doesn't boil over, which at a very high power level it might. So if that happens, take another sample and do it over again at lower power. And we're going to let this go until about the 20-second mark. You can see now the wine sample starting to boil, and it's boiling gently. That's good. It probably boils and stops as the power level comes in and out. I don't know, but anyway, we're going to keep an eye on it. I know from experience that when I get to about the 20-second mark, I've got enough boiling. Okay. Now, we're going to take the boiled sample and we're going to put it into one of the 15 milliliter conical tubes that's provided with the kit. So these tri-stir beakers actually pour pretty well. In other words, you wouldn't think so, but they do actually make a nice pour right down here. And you can see that by boiling it, I got the level down to below 8 milliliters. So between 7 and 8 is about where you want to be. 6 to 8 is fine. Below 5, you're probably going a little too far. Okay, so I did the boiling to get it to right around 7.5 mils. Okay, now what I'm going to do with my squirt bottle, I'm going to rinse what's in there back into here. We're going to bring the volume back up to the 10 milliliters that it originally was. And you don't have to be super accurate here. You want to be as accurately measuring the 10 mils as you can and get all the red color of the wine into there, because every little bit of red color means there's some of the malic acid that might be there in there. Okay, so now it just so happens I got it right to the 10, so that's done. I've got my original wine sample back up to the 10 milliliters that it was. I'm going to mix this up. And now I'm going to make a 1-to-1 dilution of this with the 0 standard, which contains the necessary buffer ingredients to help the biopressure agent do the test. So this is one thing that's different from the earlier version of the test where we had you add boost juice to it in order to add those buffer components. Now what we found is that it's a little more accurate to just dilute the wine sample 1 to 2 and have the dilution buffer, the 0 standard as it is, provide those buffer components. So now I'm going to take this and I'm going to pour it back into the container that I did the original microwaving in. And now I'm going to take out 5 milliliters of that wine sample that we just reconstituted. And again, you want to be as accurate as you can without worrying too much. You want to make sure you get 5 good milliliters in there. I've got it down to the 0 level, so I know there's 5 milliliters in it. And I'm going to put this right back into the tube that I just diluted them up in. Okay. Again, I don't blow it out because technically it's more accurate to not blow these out. They are set up to deliver the right volume. Okay, now we are going to make a dilution, as I mentioned earlier, using the malic acid standard, the 0.0. So this has no malic acid in it, and we're also going to use it later as one of the tests that we run. So I'm going to take this sample here. Again, I'm going to take another 5 milliliter, just like I did before, of the wine. And I am going to dilute the boiled wine sample with that 5 milliliters. So now we've diluted our wine sample with an equal volume of the 0 standard. I'm going to mix it up. And I'm going to put my thing here in a water bath. Okay? Cut. So let's talk a little bit about temperature control. It's a good idea to do temperature control, and since we have a lab here, we have a water bath that's thermostated, so we can take advantage of having that kind of temperature control. You don't have to have this, and I know a lot of you are not going to have a thermostated water bath. We're going to run our test in it because we can. If you don't have access to a water bath, it doesn't matter. You can use ordinary room temperature, but keep in mind a couple of things. For example, in our lab, we have blowers that blow cold air in, and the temperature under those blowers can go up and down quite a bit. 3 or 4 degrees can make quite a bit of difference over time. So what you want to do is keep the temperatures constant as possible. If the temperature in your lab or in your winery is relatively constant, you probably don't need to worry about it. If you are concerned about it, you can simply take a tray and fill it with water and let it come to whatever room temperature it comes to, and then put your things in the water bath, just as we have done here. So we've got our vials with the biopressure agent already in them here. We have our standards, and we have our 2 wine samples, and they've been sitting in this water bath, and I have it set to 25 degrees Celsius, or about 78 degrees Fahrenheit. But again, it's a luxury. You don't have to have it. It'll help give you a little more precision. Okay, so now what we're going to do is we're going to put the samples and the standards into the reaction vials that have the biopressure agent in them and start the reaction. So in that step, you will see me open the vial, put the sample in, close the vial. We'll depressurize it by puncturing the septum with an open needle. Then we'll close it, and then we'll shake it well to get the reaction really started, and we're going to incubate it for 45 minutes, which is a little bit longer than we used to suggest for the old test. 45 minutes, the current setup seems to give you a pretty good stable endpoint. You can do it a little bit shorter or longer, it won't hurt anything, but try to keep everything roughly at the same time so you don't read something a long time later than others. Okay, so first thing I'm going to do, so today I'm going to run the 0.0 standard and the 0.4 gram per liter malic acid standard, and we're going to do a concentration calculation in the end. So you don't have to do this concentration step. You can simply run your wine samples according to the manual and get a rough idea based on the numbers that you see. So we recommend that you at least spend a little time running the test in the concentration manner as we're going to do today to get familiar with the response. So we're going to run our wine samples. We did 2 samples here. You saw me prepare one earlier. And we're also going to run the 0 standard and the 0.4 gram per liter standard so that we can calculate a number in the end. So I'm going to start with my 0 standard, and I'm going to get so I'm going to actually rinse out one of these 5 milliliter pipettes that I just used. I told you were going to get to see how we really do the test. So oftentimes we simply rinse these out with water, shake them out real good, and go ahead and use them. Okay, now be careful. You want your stuff to be clean, but things don't necessarily have to be dry to be clean. They just have to be rinsed properly and properly rinsed between samples. So I've got my 5 mil pipette here. I'm ready to pipette my first sample. So I'm going to take, if you come up here for a second, you'll see that I have my stuff in my bath arranged. You can pre-label these if you want, but I have them in labeled positions on a little rack, so it makes it easier for me to remember. I know that 1's going to be 0, 2 is going to be 0.4, 3 and 4 are going to be the cab, and 5 is going to be the Pinot Noir. Okay, so I know that ahead of time. All right. So let's take the 0.0 gram per liter standard. I'm going to open this. I'm going to leave this in a clean place, and I'm going to open this, and I am going to pipette up and then let it fall back. Just sort of rinse the pipette out, and then I'm going to take 3 milliliters here, and the way I like to do this is to take it down to where there's 3 milliliters left, and then let the whole thing deliver. It's a little safer in my view than try to hit it. So I've got 3 milliliters in there now, and I'm going to go ahead and put that right in the sample, and I'm going to let it drain in 1, 2, 3 and pull it out. Immediately cap the vial, put the cap on very firmly, and now what you do is, now that we've added the sample or the standard to the vial, we have to do the depressurization. You want to do that immediately. Take the sample out and then remove the vial insertion assembly and leave it removed until you finish all the samples. And you simply put it on here like this, as we'll also do later when we measure, and do 1, 2, 3. This brings the pressure inside here to ambient pressure to get everything started. Then give it a good shake, holding it by the cap, put it back. Now we're going to go ahead and do all the rest of the samples, which we won't show because we're just going to, in the interest of time, finish everything. And then when we come back, we'll be ready to do the test. Before we do that, I will be sure to put this back on and put it on tight. So our 45 minutes is up now, and it's time to do the readings. So as it says in the manual, we're going to take each vial in turn. We're going to read it with the vial insertion assembly, get our reading, write it down, and move on. So as you can see now, the everything's ready. I have the unit here. I turned it on. I've made sure that it's set to kilopascals. You can see down here in the little corner, and it's ready to go. Here's the insertion assembly. I'm just going to read these each one at a time. So starting with this one, we take the sample out, we give it a shake for 5 seconds, put it down and read it immediately. Okay, it reads 1.00. That was the highest number I saw. I'll write that down. Now we're going to go on to the next sample. Again, shake, put down and read. And this is reading 3.64. That's my 400 or 0.4 gram per liter. What was it? 3.24? 3.54. Sorry. And now, well, here's something to notice. Notice how it hasn't returned all the way to 0. It should come all the way back to 0.0, which suggests there might be a little bit of a plug in there. So I'm going to make sure that it's not plugged up at all because it might mess up the next readings. I have, for that, a device to blow it out. Where did it go? So I disconnect my assembly and I reconnect it to this little thing, which I think we'll be providing for you. or you can devise one of your own. Either way, you just want to blow it out and make sure that it's flowing freely. Okay, a little bit of liquid came out, which sometimes happens. All right, so now I'm going to go ahead and reconnect. Okay, reading low number, on to the next sample. 1, 2, 3, 4, 5. A 1.95. On to the next sample. 5.38 was the highest number I saw. And then finally this last one. 5.68. So just looking at this information here real quickly, this was our zero. It came up about 1 kilopascal. This was a 400 standard. It came up about 3.54 if I recall correctly. We'll go back and check what the number was. Here, this particular wine sample, which we know is close to complete, came up 1.95, and you can tell it's. We'll do some calculations later to figure it out, but with this data you can find, you'll see that this number is coming somewhere around 100 or so. The Syrah, on the other hand, or this particular wine that we have here, was it a cab maybe? I don't remember. But anyway, you can see that these two, which are replicates of each other, came up around 5.38, 5.68. So these numbers are clearly above the 400, plus they've been diluted by a factor of 2 to begin with. So this number is coming in somewhere around probably close to 1,000. So that means that this sample has not completed malolactic. This one likely has or is close to it. And we'll go back and look at the numbers later to see what they actually calculate out to be. So that's pretty much all there is to making the measurements in the lab. Here I'm doing the calculations for the test we just ran. So over here you can see the grams per liter of malic acid, the two standards that we ran, 0.0 and 0.4. Here's the kilopascal pressure response that we saw. Here is the value for the Pinot Noir and for the Cabernet replicates that we had. Here's how the calculation is done. It's 2 for the fact that we diluted the wine in 2 times the 0.4 standard times the difference between the response of the sample minus the response of the 0 divided by the difference of the response of the standard and the response of the 0. And that gives us a result of 0.29 grams per liter malic acid. Likewise, for the two replicates of the cab, we get 1.3 and 1.4, pretty close together. Obviously, these are a long way from having finished malolactic fermentation, whereas the Pinot Noir is pretty close to finished. That's pretty much all there is to running the MLF assay.